there are these few parallel programming concepts which I would like to highlight before we move on. First thing is process. So the formal definition is the process is the program under execution. But more practically, let's say, I want to understand what the process is. Then let's understand it with an example. Let's say you have C program. Now let's say you compile it. You compile that C program, and it will be in the secondary storage or on your disk. But when you run /a.out, that program will be loaded into the main memory or the DRAM of your system, and at that time that program becomes process, because that binary file is loaded in the DRAM of the computer, as well as the other data structures will be associated with it for the sake of its execution. Let's say it will be allocated a heap for dynamic allocation of the memory, because you might declare some memory using malloc or something inside your code, and for that you need space. To allocate a variable, you need a space. So for that, heap will be allocated. Heap will be allocated to your process, which is your so that process is a collection of multiple things. One is that binary, another is heap, and then you might also declare some variable statically for using, like, let's say for example you declare int a. So such allocation of a variable will be done on stack. So for that you need something called a stack. So inside process there is a this binary, then stack, then heap. Then you need to also take care of like what is the current stage of execution, where I'm currently, which instruction I'm currently executing. For that you need program counter and so on. So one process might have multiple things, and so one process will have multiple things, and it will be private to that process. And the examples of the process are Notepad, Chrome, Word is also a process. And so whenever you click on your Chrome, when you launch your Chrome, it will be loaded in the main memory, and it will be allocated all this stack, heap, and all those things for its execution for its execution. So yeah, that's it. And next term is thread. Thread is, technically, if technical definition is, it's a lightweight process. But let's understand it practically. So let's say you have this word, which I told is a process. Word is a process. Now, what can be a thread inside that word? Word is a process, right? So each process might have multiple threads inside it. And let's say if a word is a process, then thread can be something like a spell checker inside that word. Because let's say you're typing, and there might be something like you write it wrongly, wrong spelling or something, and it will autocorrect it. So that's one thread which is working inside that process known as word. And it is working independently, and there might be several other threads also which are doing different things. So what's the difference between thread and process? First of all, thread is a part of process, so each process might have multiple number of threads. But why it is called lightweight process? The reason is that threads have multiple things in sharing. For example, the threads share the code part. So binary file that is loaded is shared among all the threads. Then there is heap, which is also shared among all the threads. But okay, so there are multiple things that are shared, but there are also a couple of things that are private to each thread. For example, stack is private for each thread. Then there are several registers which are privately allocated to each thread. Then as each thread is executing independently, it also needs its own separate copy of program counter. So all these things will be private to the thread, but there are multiple things that are shared, like file systems will also be shared among all the threads. So since multiple things are shared, it is known as a lightweight process. Okay, so that's a bit about thread. But then coming to operating system. So think of operating system as a manager. So you want to be able to talk with hardware directly, at least for the high level machines that we have nowadays. So for that you need someone like manager who talks on your behalf to hardware. And so let's say you want to print something on the screen. Then for that you need to invoke a system call like write, and that write system call will instruct the hardware to. So write system call is written inside the OS, and then that system call will tell the hardware to print something on screen. So for each and every for each and every thing we have to, for each and every functionality of the hardware we need to talk with OS, and it's kind of a software that manages the hardware, and it's also the software with which the user interacts. And there are multiple examples of OS like Windows, Android, Linux, even Mac OS is the example. The fourth thing is the hardware components itself, like cache. Cache is a very small memory which is close to the processor. And advantage of having such a small memory is that access to this is very quick because it's very small. The size is small, so indexing it is very fast. But there is disadvantage that its size is small, so you won't be able to store many things inside it. But whatever you can store inside it, the access will be very very fast, and processor can get it with very very less latency. Then comes the main memory, which is slightly below the hierarchy, below in the hierarchy as compared to the cache. So main memory, so nowadays main size of the main memory is, as you people know, like 8 GB, 16 GB is normal for the normal computers, while for cache you might see that size are just in few MBs, like 256 MB or something like that. Not okay, so that's the difference. But yeah, the main memory can handle, can load a large amount of data in it, and if the data is not present in cache, then processor or core will go into the main memory. And then comes the core. Core is actually the hardware component on which the thread runs, and there is this concept that thread can jump from one core to another core, which means that if let's say we have two threads per let's say there are two threads allocated to one core, and let's say that thread number one is currently being executed by the it's currently running on the processor one, and let's say there are five processors, and let's say it happens that thread 1 needs an IO, then it will go for IO, and processor 1 will pick the thread 2 which was allocated, scheduled on it, and starts running it. By the time, let's say, thread 1 have finished its IO and it wants the processor again, but processor 1 is busy, so it might go to some other processor which is processor number, let's say, 4. In that case, we can say that thread 1 has jumped from processor number 1 to 4. So that is something called as thread jumping of thread.